Welcome to Quantum EVM and Cellframe Academy, where you'll be introduced to the quantum computing company Alice and Bob.
I'm Theo Perona. I'm the CEO and co-founder of Alice and Bob. So at Alice and Bob, we're building a universal fault-tolerant quantum computer out of a new kind of superconducting circuits called the CAT qubit. They're able to correct autonomously half of the errors that limit the performances of a quantum computer.
How elliptic curve encryption works and why his algorithm is able to crack that.
The thing that is fun is that elliptic curve cryptography is much harder for a classical computer to break than RSA. And thus, for example, in applications like Bitcoin, where it's used, they tend to use keys that are much smaller because when you try to think only of classical attacks, you don't need such long keys. But from a quantum computer point of view, those two are completely equivalent. So actually, elliptic curves with today's key size will be broken a bit earlier than RSA. The study made by Google back in 2019, I think, showed that it would take about 20 million physical quantum bits to be able to run Shor algorithm and break RSA 2048. The idea is to say that when you look at those 20 million required, actually only 0.03% of the qubits are here to compute, meaning the remaining 99.97% are overhead. What we do at Alice and Bob is that we make those qubits compute. And so what we've done in the past is that we designed a novel type of qubit called the CAT qubit that corrects half of its errors natively through a hardwired feedback loop. And by doing so, we gain a square root ratio on the overhead. So we're basically left to 30 to 1 instead of 1,000 to 1. And so what we showed is that if you take all the algorithm together, you end up requiring only 350,000 instead of 20 million. So you gain a 60-fold improvement. And the last result we just published a few days ago showed how to keep improving upon that. So we gain another almost 4-fold. We're now slightly below 100,000 qubit required. So basically, to wrap up CAT qubits, it's a driven qubit that is able to increase exponentially its bit flip time at a linear constant phase flip without any prefactor.
So how much closer do you think this approach takes us to getting to something large and scalable, like an implementation of cracking elliptic curve?
For me, the right target, the moment where quantum computers start to be in orbit, if you want to feel the analogy with the space race, is when you get about, between 50 and 100 logical qubits with error rate that are low enough, meaning lower than 10 to the minus 6. Is that we could build 100 logical qubits with error rate of 10 to the minus 8 with as few as 1,500 cats. And 1,500 cats is something IBM is close to be able to manufacture. With our novel architecture, I guess elliptic curves would take something like 40,000 cats to run, and Shor slightly below 100,000 for RSA. Sorry. So the finding of this theory paper is that we have an architecture feasible with today's technology that opens a path to get to those machines of 100 logical qubits and more pretty soon.
Discover quantum EVM and migrate Web3 assets to quantum safety, powered by Cellframe, the only scalable post-quantum network to build on.